Hello, in this video we are going to solve the following problem, Mathematical Olympiad, number theory. The topic is divisibility. Show that n squared plus 3n plus 5 is not divisible by 121 for any integer n. This problem is taken from the following book. That would be a good idea if you pause the video at this point and give it a try. If you cannot solve the problem on the first trial, on the next slide I will show you a first hint for how to proceed. And still, if you have problems and you cannot solve the problem, the slide coming after that I will show you a second, more detailed hint. If you don't want to see the hints and you want to try the problem on your own, please pause the video at this point. Okay, the first hint that I want to provide for you is to apply proof by contradiction. On the next slide, I will show you a more detailed hint. If you don't want to see that, please pause the video at this point. Hint 2. Note that the expression given in the problem n squared plus 3n plus 5 can be written as n plus 7 times n minus 4 plus 33. Okay, so my goal is to show that for all n from the set of natural numbers, n squared plus 3n plus 5 is not divisible by 121. In other words, 121 does not divide n squared plus 3n plus 5 for any integer n. So this is what we want to show. Okay, we want to prove this by the method of proof by contradiction. Assume that this is not the case. Assume that this is not the case. And there is an integer. By the way, here the problem wants us to do it for integers, so if you don't mind, let me just change it to z. Okay, so there is an integer n such that 121 divides n squared plus 3n plus 5. Okay, so then we want to reach to a contradiction if this is the case. So according to what is given in the hint, n squared plus 3n plus 5 can be written as n squared plus 3n plus 28 or minus 28, let me write, minus 28 plus 33, because 33 minus 28 is just 5, but then the first and the second and the third term together we can factorize them, so it becomes equal to n plus 7 times n minus 4 and then plus 33. Okay, so if this is not the case, then I have to accept that this number is divisible by 121 for some integer n. So this means that this number is divisible by 121. So 121 divides n plus 7 times n minus 4 plus 33. So this means that 11 also divides n plus 7 times n minus 4 plus 33, because if a number is divisible by 121, of course it is also divisible by 11, but because 33 itself is divisible by 11, this means that n plus 7 times n minus 4 should also be divisible by 11. But now 11 is a prime number, And we know that if p is a prime number, and we know that a prime number divides the product of two integers a and b, then at least one of these numbers should be divisible by p. So it means that either p divides the first one or p divides the second one. So that's also the same here. So 11, which is a prime number, divides the product of two numbers, n plus 7 and n minus 4. So it means that at least one of them should be divisible by 11. In other words, 11 divides n plus 7, or 11 divides n minus 4. But now, interestingly, I want to show that if 11 divides n plus 7, it automatically divides n minus 4. And if 11 divides n minus 4, it automatically also divides n plus 7. So this or can be changed to and. Okay, and that is simple. Why? Because n plus 7 minus n minus 4 is indeed 11. Okay, so if this is the case, it means this part is divisible by 11. 11 is also divisible by 11, so it means that n minus 4 should also be divisible by 11. Okay, so if this is the case, this one is also the case, and the other way around. If this one is divisible by 11, if this part is divisible by 11, 11 itself is also divisible by 11, so we can conclude that n plus 7 is also divisible by 11. So this means that based on this line of arguments, I can change that 11 divides n plus 7 and 11 divides n minus 4. In that case, it means 11 times 11 divides n plus 7 times n minus 4. So this means that 121 divides n plus 7 and times n minus 4. Okay, so this is what we get. So on the other hand, we know that this expression is divisible by 121. This expression is written in this form. Yes, so what we know that 121 divides n plus 7 times n minus 4. On the other hand, we, based on the assumption, this is also the case, then it means that the difference, if two numbers are divisible by the same number, the difference between them should also be divisible by that number. So this means that 121 should divide 33, but this is a contradiction. In other words, if you don't believe that what the problem says is correct, and then you assume the negation of that, then you have to accept that 33 is also divisible by 121, which is an apparent contradiction. So this means that this is indeed true. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.